Hello everyone and welcome to this video presentation for CHM 561 Quality in Analytical Measurement. My name is Muhammad Shahiminin and today we are going to dive deep into the Chapter 7 to explore a critical framework that governs the modern analytical laboratories ISO 17025 Laboratory Accreditations. Think about this for a moment. Every day, decisions worth millions of dollars and decisions affecting public health, environment safety, and pharmaceutical purity rely entirely on data generated by chemical laboratories. But how do we know we can actually trust the data? If an analytical balance is miscalibrated or if a chemist uses an unvalidated method, the numbers will get completely meaningless. In analytical chemistry, a quality system isn't just a luxury. It is what stands between accurate science and catastrophic failures. That is where ISO 17025 comes into play. It is the definitive international standard specifically designed for testing and calibration laboratories. Its main objective is to establish the general requirement for lab competence, impartiality, and consistent operation. Now, a very common misconception in quality management is confusing between ISO 9001 with ISO 17025. Let's clear things right out because they serve completely different purposes. ISO 9001 is a generic quality management standard. It deals with certifications. It proves that an organization follows standard operations procedure whether they make car parts or bake bread. ISO 17025 on the other hand deals with accreditations. It doesn't check if you have a management system. It explicitly proves a technical competence. It tells the world that your lab has a precise scale, calibrated equipment, and validated scientific method that necessary to generate a valid and legal analytical data. To understand how a lab achieves this level of trust, we look at the core requirement of the standards, starting with resource requirements under the clause 6. First, we look at the personnel. A lab can have the most expensive instrument in the world, but if the analysts are not properly trained, the results are compromised. ISO 17025 requires strict documentation of the staff competence, ongoing training, and authorization to perform a specific analytical procedures. Second, the standard regulates the facilities and environmental conditions. In analytical chemistry, ambient temperature, humidity, or even airborne dust can alter the chemical reaction and instrument performance. An accredited lab must continuously monitor and record these conditions. Third, we have equipment and methodological traceability. All analytical instruments must be routinely maintained, verified, and calibrated. But calibration isn't just about resetting a machine to zero. It requires methodological traceability. This means the calibration of your lab instrument must be linked back to an unbroken chain of the comparison reaching all the way up to the international standard, such as SI units. This ensures the measurement taken in our lab will match a measurement taken anywhere else in the world. Moving on to clause 7, we look at the process requirements. This covers everything from how a sample is received, tracked, and tested, to how the final report is generated. A cornerstone of this section is method validation. A lab cannot just pick up method out of thin air. They must be mathematically proved that the chosen analytical method is fit for its intended purpose, looking at the parameters like linearity, accuracy, and detection limits. But perhaps the most critical concept for us as analytical chemistry students is the measurement uncertainty. In real science, no measurement is ever 100% perfect. There are always random and systematic errors. ISO 17025 dictates that a lab must evaluate and calculate its measurement uncertainty. When a lab reports a results, it is never just given as a single flat number. It is expressed using this formula: y equals to y plus or minus 0, where a little y is our actual measurement estimate and the capital U is the expanded margin of uncertainty. This transparency shows exactly how much confidence we can place in the chemical value. Furthermore, Labs must regularly participate in external professionally testing, which is essentially an exam which there are different lab tests, the same blind sample to verify their accuracy against one another. So, how does a laboratory actually gain these accreditations? It is a journey. It begins with a gap analysis to see what the lab is missing. Then the lab documents its quality management system, creating through the standard operating procedure. Before the official assessment, the lab must conduct its own internal audit to catch any non-conformance. Finally, an authorized third-party accreditation body steps in to conduct an intensive on-site audit. If the lab passes, they are officially granted ISO 17025 accreditations. To wrap things up, ISO 17025 is far more than just a mountain of administrative paperwork and academic exercise. For chemical laboratories, it is the fundamental framework that ensures the data integrity. It transforms a facility from a place where people do chemistry into a highly competent, globally trusted institution that can back up its result with hard and reliable evidence. Thank you so much for watching my presentation. I hope this gave you a clear, comprehensive understanding of how laboratory accreditation shapes quality in analytical measurement. Have a great day. And here's the reference screen you can check. Thank you so much.